Welcome to a demo on hierarchical clustering. In my previous video, I've given you a no-code demo of hierarchical clustering, but in this video, I'm going to give you a Python code walkthrough of it. I will also show you the demo using my platform experienceddatascience.com. You can also access the code as well as execute it directly from your browser. You do not require any installation and it will be fun. So let's jump in. Let me first start by explaining the basics of hierarchical clustering. Let's say you have a data set with a lot of columns. Hierarchical clustering will find the distance between each data point, and all the points which are close to each other will be grouped together. And then it will organize all the data in form of a hierarchy. You can also specify a threshold to form the clusters. You can think of the threshold as a way to cut the hierarchy to form clusters. For example, if you specify a low threshold, you'll get many clusters, but if you specify a high threshold, you'll get less number of clusters. Now let us see this in action using a demo. Let me first start by going to my platform experienceddatascience.com, and I will select the experience hierarchical clustering. Now here you see multiple options, and let me go ahead and select the option to code. Now in this demo, I'll be taking some real world data which is related to business school rankings which have been developed by Financial Times. I've already set up the data set, so let me go ahead, select it and copy it and make it ready to use. Alright, so the data set is now copied, so let us start with the Python coding. Let me also specify the name of the file in which I can save my work. Now here you see two windows. The left hand side is a VS Code editor where we'll be writing all the Python code, and the right hand side window is where you'll see all the output. Now here you do not need to install any libraries or make any Python installations. The code will work directly from your browser. The editor is already linked with the data set selected, and the input data will be available in a data frame called as df. And we can output any data by storing it in a data frame called as df_out. Let us first start by displaying some sample data. So I will copy the data frame df to the data frame df_out, and let us see some sample data. So this data has got various information such as the rank of the business school name, the location, the salary, the course length, percentage of female students, carbon footprints, and much more. In total, it has got about 30 columns. Now let us import some libraries, and we will need the Python pandas as well as the NumPy library. We'll be also using the scikit-learn as well as the SciPy library, which has got all the hierarchical clustering algorithms. Let us first start with some data preparation. Now this data has got numerical columns such as the weighted salary, the career progression, rank, the employed in 3 months, etc. So all these numerical values has got different scales. For example, if you take salary, it is in thousands, while if you take the column employed within 3 months, it is in percentage. So we need to convert them into a common scale, and for this we are going to use the standard scalar function. I can first start by selecting the numerical columns by using the select d types as number, and then I will select only those columns and apply the standard scalar to bring all the numerical values to a common scale. Let us now store the results in this data frame and pass it to df_out and see the results. So here you see that you only have numerical columns and they are all at the same scale. Now let us do the data preparation for the non-numerical columns. I will only take the column location by primary campus, and we need to convert it into 1 or 0, also called as a one-hot encoding. I can do that with the Python get_dummies method, and let us see the results. So here you see that instead of one column location, we have multiple columns which corresponds to each location, and there is a 1 if the school is in that location, else it is 0. For example, here we see that the first record is for a business school in France. Now let us combine these two data frames, the data frame for the scale values of numerical columns and the data frame for the one-hot encoding values for the non-numerical columns. And let us see on how this combined data frame looks like. So basically this has got both the scaled as well as the one-hot encoded values. Now my friends, we are ready to do hierarchical clustering, and we will use the linkage function, which is the part of the SciPy package. Now this function takes two arguments. One is the process data frame and the second is the method for hierarchical clustering. And we'll be using the most common method, which is called as WAD. Let me store this output in a variable called linked, and we can also convert that into a data frame, and let us see its content. Alright, so the output of the linkage function is also called as a linkage matrix. The first two columns indicate the number of input records, and the third column indicates the distance between the two input records. For example, the first line corresponds to the school number 4 in the data and the school number 6 in the data. And the third column is basically an Euclidean distance between the data corresponding to the school number 4 and school number 6. And hierarchical clustering will combine the closest records and put it in one cluster. The fourth column is an indication on the number of records in a particular cluster. And here we see that there are two schools in this cluster. However, as the hierarchy is building, you will see that the number increases and there will be more schools at the higher levels of an hierarchy. So in total there are 99 schools in the data. So you can see that the top hierarchical node will have all the 99 schools, which is shown over here. Now, as I told you earlier, that we can cut this hierarchy using a threshold, and we can then assign each school to a cluster. Let us take a threshold value of 10, and we can use the function fCluster, which will assign a cluster number to each school based on a threshold. The output cluster are stored in this variable called as cluster. We can now assign back the cluster number to the original data. Now let us run this and see the results. So here I have the original data, but if I scroll to the right, I will also see the cluster number. For example, the first school is in cluster number 1 and the second school is in cluster number 3. Now let us download this data and open it in Excel. Right, so once again here I see all my business schools, and here at the end I see the cluster to which the school is assigned. So overall I see that there are about 11 clusters. So now I invite you to try it out with a lower threshold value of 5, and you can see if the number of cluster is increasing or decreasing. Now if you want to access this code, you can go to the top section code list, select the first one which is marked as play code, and then copy it to the editor. So hopefully my friends, you have enjoyed this video. Do not forget to also watch the no code version of hierarchical clustering, and see you soon in another exciting demo video.